In this video, we're learning how to find the vertex of a quadratic that's written in intercept form. And if you look at the top of the screen, we have some steps that we can use when finding the vertex of a quadratic in intercept form. So what we're going to do first is find the x-coordinate of the vertex using the equation x is equal to p plus q over 2, and I'll explain what that means as we go through some problems. And then we are going to plug the x-coordinate of the vertex back into our equation to find the y-coordinate. So let's jump into example 1. So in example 1, we have the quadratic y equals the quantity of x minus 4 times the quantity of x plus 2. And what we have to remember is what intercept form is. So intercept form looks like this. It's a times x minus p times x minus q, where p and q are the x-intercepts. So p, and q are the x-intercepts. So in our given equation, our p value is 4, and our q value is -2. So this means that our x-intercepts are 4 and -2. And for this problem, I'm actually just going to sketch this so we can see where this equation comes from, this p plus q over 2 equation comes from. So we're going to do 1, 2, 3, 4. We're going to put an x-intercept there. And then -1, -2, we'll put an x-intercept there. And our parabola goes up, so it's probably something like this. And now what you may notice is that the axis of symmetry is going to be right in the middle of those two intercepts. So it's going to be right here. So what we're trying to do is find the middle of those two intercepts. That's going to be the x-coordinate of our vertex and our axis of symmetry. And to find the middle of two numbers, you're just finding the average, which is where this equation comes from. So you're basically just finding the average between your two intercepts. That's going to give you the x-coordinate of your vertex. So let's go ahead and use the equation to find the x-coordinate of our vertex for this problem. So the x-coordinate of our vertex is equal to p, which in this case is 4, plus q, which in this case is -2, divided by 2. And we're going to simplify this. 4 plus -2 is going to give us 2. We have 2 over 2, which is 1. So the x-coordinate of our vertex is 1. And now to find the y-coordinate, we're going to plug that back into our equation for x and solve for y. So we have y equals, instead of x minus 4, we're going to have 1 minus 4, times, instead of x plus 2, we're going to have 1 plus 2. And we're just going to simplify the right side. So 1 minus 4 is -3. 1 plus 2 is 3. 3 times 3 is -9. So we get that our vertex is at 1, -9. Moving on to example 2, we have y equals -3 times the quantity of x plus 5 times the quantity of x minus 3. I'm not going to draw a diagram or a graph for this one, but if you guys want to, go for it. So let's start by writing down our p and our q value. So p is -5, and q is +3. And now we're going to start by finding the x-coordinate of our vertex. So we know x is equal to the sum of p and q, so -3 plus 5, or -5 plus 3, sorry about that, divided by 2. And we're just going to simplify this. -5 plus 3 is -2 on the top, over 2. -2 over 2 gives us an x-coordinate of -1. And now we're going to plug that back in for x into our original equation and solve for y. So we have -3 times -1 plus 5 times -1 minus 3. And we're going to simplify the right side. So we have -3. -1 plus 5 is 4. -1 minus 3 is -4. And now let's multiply this out. -3 times 4 is going to give us -12. So we have -12 times -4, which gives us a y-coordinate of 48. So our vertex is pretty high up. So our vertex is going to be the point -1, 48. Let's go through 2 more examples just to make sure we've got this down. So for these last 2 examples, I encourage you guys to pause the video and try them on your own, and then you can watch me work through them to make sure you've solved them correctly. So let's jump into example 3. First, we're going to write down what p and q are. So p is -7 and q is -2. And it doesn't matter which set of parentheses used for P and Q. You could say P is -2 and Q is -7. I didn't mention that in the last two problems. So now we're going to find the x-coordinate of our vertex. So x is equal to the sum of P and Q divided by 2. -7 plus -2 is -9 on the top. We've got a 2 on the bottom. So we get -9/2, which I'm going to write as -4.5. You can also leave it as a fraction. It doesn't matter. And now we are going to find our y-coordinate by plugging that back into our equation. We're going to have 2 times -4.5 plus 7 times -4.5 plus 2. And we've got to simplify the right side. So we keep this 2 on the outside. -4.5 plus 7 is going to give us a positive 2.5. -4.5 plus 2 gives us a -2.5. And now let's just multiply 2 times 2.5 is going to give us 5. So we have 5 times -2.5. And if you guys multiply this out, you can use a calculator or do it out by hand. You should get -12.5 as the y-coordinate of our vertex. So we get a vertex of -4.5, -12.5. And we'll just box our answer. And moving on to example 4, we have y equals negative the quantity of x minus 6 times quantity of x plus 1. So let's figure out what P and Q are. So P is 6, Q is -1. And let's start by finding the x-coordinate of our vertex. So we are going to take the sum of P and Q, divide that by 2. 6 plus -1 is 5. So we have 5 over 2, which I'm going to write as 2.5. And now we're going to plug that back in for x and solve for y. So I have negative on the outside, 2.5 minus 6 times 2.5 plus 1. We're going to keep the negative on the outside. 2.5 minus 6 is going to give us a -3.5. 2.5 plus 1 gives us a positive 3.5. And we have two negatives, so we know our answer is going to be positive. So we're going to do 3.5 times 3.5, which is going to give us a positive 12.25 as the y-coordinate of our vertex. So we get a vertex of 2.5, 12.25. So hopefully this video helped you guys understand how to find the vertex of a quadratic that's written in intercept form. You really just have to remember that the x-coordinate of the vertex is going to be right in the middle of those two intercepts. So you just want to find the average of those two intercepts to find the x-coordinate of the vertex, and then use that to find the y-coordinate by plugging it back into your equation.